The IUPAC Periodic Table of the Elements and Isotopes, IPTEI. We have with us today Dr. Norman E. Holden of the National Nuclear Data Center of Brookhaven National Lab, BNL, in New York. Dr. Holden.
I've been asked to talk to you today to provide some background on why we created the interactive periodic table of the elements. So why did we decide to create this? Besides thinking it would be a cool tool to use in their spare time, there was a desire to create an educational tool. To provide some history, more than a decade ago, the International Union of Pure and Applied Chemistry noted that students and teachers at the high school, college, and university levels, and the public, were generally uninformed about isotopes. Hard as it is for a scientist to believe, most had never heard the term, or words such as danger, radiation, harmful, radioactivity, and atomic bomb project came to mind. The word should be used in connection with isotopes would be terms such as useful, beneficial, life-saving, and essential for life were never expressed. A joint IUPAC educational outreach project of the Inorganic Chemistry Division, Division 2, and the Committee on Chemistry Education, CCE, was proposed to develop a digital, interactive periodic table of the elements and isotopes to change the thinking of students and teachers and the public about the importance of both stable and radioactive isotopes in everyday life in ways that they never imagined. To explain the importance, we must go further back in history. You're getting both history and science in this video. Lucky you. In 1869, Dmitry Mendeleev constructed his original table of isotopes, using as his organizing principle his formulation of the periodic law. If chemical elements are arranged in order of ascending values of their atomic weights, at certain regular intervals or periods, elements occur having the same or similar chemical and physical properties. At the time, atomic weights were considered constants of nature, like the speed of light. It's now known that the classification of elements depends on the atomic number, the positive charge on the nucleus, not on the atomic weight as previously thought. All elements have stable and unstable isotopes. In the 20th century, it was found that the atomic weight of an element was not a fundamental property of the element, but could be calculated. Instead of measuring the atomic weight, it was calculated by the product of the isotopic composition multiplied by the atomic mass of the stable isotopes of the element would give you the atomic weight. Students, teachers, and the public must fully understand the concept of isotopes to appreciate the following three issues. Instead of measuring atomic weights, they can be calculated as just mentioned. Why atomic weights are no longer considered constants of nature, and why the atomic weight values of some elements are listed with intervals. The IPTEI is based on Mendeleev's periodic table. However, instead of displaying chemical and physical properties of each element, the IPTEI lists all stable and long-lived radioactive isotopes of each element that contribute to the atomic weight for that element. The applications provided for each element are exemplary and not intended to encompass all isotope applications of that element. Overall, the IPTEI presents 432 applications from 96 different elements. To emphasize the importance of isotopes, applications for each element are highlighted for their practical uses in science and in everyday life in one or more of 7 categories: biology, earth and planetary science, forensic science and anthropology, geochronology, industry, medicine, and the production of other radioactive isotopes. These applications provide proof that isotopes are beneficial, useful, life-giving, and important to us. 2 issues were discussed at the start of these projects, which were the educational outcomes that were hoped for from this educational outreach project, and how feedback from the users could be generated and how this information could be measured. It is hoped that the topics being addressed would be incorporated into course material of chemistry teachers, and that students would absorb the concepts and gain a better understanding of the useful and important role that isotopes play in everyday life. The feedback loop would involve assistance from the national representatives of the CCE and the IUPAC national adhering organizations, the NAOs. It's hoped that these groups would interact with teachers in their countries to provide a channel of communication between the teachers and IUPAC. For the digital interactive table, a pop-up questionnaire will be developed for users to the website to provide feedback on the usefulness of the data and the ideas presented. Suggestions on improvement of the material will also be available. IUPAC would serve as a link in forwarding this information to both scientists and educators involved in the continuing improvement of these projects. The CCE could provide a link to the national curriculum developers in their countries. In the century between the creation of IUPAC in 1919 and the present day, much has changed with respect to isotopes. If we compare the situation midway in 1969, there are a total of 1,665 isotopes and 105 elements. Moving forward another 50 years to the present time, the IPTEI lists a total of 3,345 isotopes and 118 elements. Although about 90% of the chemical elements were known half a century ago, as many new isotopes have been discovered in the present half century as were known 50 years ago. What does this increase in total known isotopes in the last 50 years imply about the possible number of new isotopes that might be discovered in the coming half century? Well, thank you for your time today. We hope that you find the digital interactive periodic table of the elements and isotopes to be useful, informative, and fun to use.